Yeah, I could see it.
Okay. The angle that they're asking for, this question mark here, is 113 degrees. Okay.
Yeah.
And the reason is these angles, these are called alternate interior angles. Alternate interior angles. Sometimes AIA is what's used when you have two parallel lines and they're cut by a transversal. This angle, I'll call this angle 1, is equal to angle 2, and angle 3 is equal to angle 4. And that's because they alternate over this transversal. This line right here is called a transversal. Now, do you know what this angle measure is right here that I'm drawing in? Or
Um,
or even this one down here? Do you know how to find that?
I think I subtract 113 from 180.
Exactly. So that's 67 degrees. And then by vertical angles, these are congruent. So this is also 67 degrees. Alternate interior angles means that this one up here is also 67 degrees. So what do you notice about the sum of these two? I think you kind of already said it here.
They equal
This
180.
sum is 180. So there's really two situations here. They either are equal, the angles, or they add up to 180. All right, let's take a look at 13. I'll snip that in next.
Are you doing your geometry?
Let me get this in here, snip this in. All right, we're gonna start on the next problem here. Pasting it in now. Okay, solve for x. Okay, so x is here, 55 is here. Are these angles equal or do they add up to 180? And if you're not sure, that's okay, but what do you think?
They're equal.
They're equal. They're equal by vertical angles. Some geometry classes really want you to figure that out, figure out why that's the case. So you're setting them equal, and then you're dividing both sides by 11. So x equals 5. So that means this is 55 degrees. What is, for example, this angle measure here?
I can't even do that in my head.
Tell me in words. It's what?
Wait, it's 125.
Yeah, I was going to say it's 180 minus 55, whatever that is, 125 degrees. Okay, excellent. Let's move to number 14. There it is. Okay, so 14, I'm going to snip this one in. So we've covered alternate interior angles. We just talked about vertical angles. There's a couple more to know about. So I'll paste this one in. All right. So there's kind of like you have to sort of make some jumps here. So this 70 degrees is equal to which angle? This one right there.
Yeah.
Do you agree with that?
Yeah.
And then by alternate interior angles, we know that this angle right here is also 70 degrees. And then the angle down here, what does it have to equal?
70?
70. Because I told you before, I said they're either equal, they're either the same, meaning they're equal, or they add up to 180. So you always have a 50-50 chance, but let's do better than that. So yeah, so 70 equals x plus 78. So what is x when you subtract 78 from both sides?
8.
-8.
Uh,
-8. Now, keep in mind here, x is not the angle. X is it's part of the expression for the angle. So if it asked for this angle right here, that angle is 8 plus, I'm sorry, negative 8 plus 78, which is 70 degrees.
Okay.
Is that okay?
Yeah.
Great. Let me grab the next picture. All right. The snip again here. Snip. Okay. These angles are on what's called the same side of the transversal. Okay, so they are what are called consecutive. These are consecutive. And consecutive angles, these always add up to 180. So if you don't like that explanation, 100 is equal to this angle down here, which is 100 degrees. And then because 100 degrees and this 26x plus 2, they're on the same line, they must add up to 180.
Okay.
So we know that 100 plus 26x plus 2 has to equal 180. So we're going to solve for x. To do that, let's just combine these like terms first. So that's 102 plus 26x equals 180. Subtract 102 from both sides. So we get 26x equals 78. Divide both sides by 26. And x equals 3. So it just wants x, so we're done there. If we wanted the angle measure, we'd have to go back and put that value back in. I can't tell if you need this question done. It's cut off at the top here. Let me snip it in here and see if you can tell me if it is or not. If it's needed. This one right here.
Oh yeah.
You need that?
Yeah.
Okay. Can I put a number on it? Is this 16?
That's the next one. Whatever we just did.
Yeah, we just did 15, so this is 16. I'm not seeing 17.
17.
Take a
I
look
need
here,
to
maybe.
do it, but I probably didn't send it.
Oh, nope. This is my mistake here. I did find 16. This is not 16. This is something else. Okay, so here's 16 coming in. We're gonna get that snipped in here. Coming in. All right. There is 16. Okay. What is this symbol right here? Do you know what that means?
It's a right angle.
It's a right angle. Its measure is 90 degrees. So you can even just put 90 degrees in there if you want. These two lines are parallel. The ones going to the sides. This is the transversal going up and down. So this 90 is equal to this 90 up here. And then by vertical angles, this right here is equal to this 90 down here. So as I've said many times, because I really want you to just know this for your test or quiz or whatever you got upcoming, is that you either set them equal or they add up to 180. In this case, you set them equal. Is it okay? Is it clear why they're equal?
Yeah, because they're vertical.
They're vertical because
angles.
this one and this one alternate. They're alternate interior angles, then the vertical angles there. Add 5 to both sides. 95 equals 19x. Divide both sides by 19. Does work. X equals 5. All right, so 17 is the next one on your list here. I'm going to snip that in to work through. When you look at 17 on your side, I'm going to get that snipped in here. Do you know if the angles are equal or add up to 180 by looking at it? What say you here, Maddox? These are parallel.
8.
This is the transversal. So whenever you have a parallel lines and a transversal, if I give you like this angle down here, the one on the other side up above here, these are called the alternate interior angles. They are always congruent. These ones that alternate on either side. So these are equal. Is that okay?
Yeah.
If it's not, I'd really like to cover this in more detail if it's not, because we have the time. I want to make sure you got it. The only times they're not equal, the only times they add up to 180 is if they're like 1 and 2, angle 1 plus angle 2, they add up to 180. If they're on the same side of a transversal and they're in the interior, like let's say it's angle 1 and angle 2, angle 1 plus angle 2, they add up to 180 because they're on the same side of this thing. They're on the same side of it. But in this picture, they're not on the same side. They're on opposite sides, or they alternate. So that's why they're equal. So to solve this, I suggest subtracting 5x from both sides. That gives you 10 equals 2x minus 8. Add 8 to both sides. 18 equals 2x. Divide both sides by 2. So x equals 9. Now, it says the measure of the angle this time. That means you're not done. That means you just found x is not the answer. X is the intermediate answer. You have to put 9 back in to one of these. So let's go 10 plus 5x. Let's go say, okay, I got 10 plus 5x. I know that x is equal to 9. 10 plus 5 times 9. 10 plus 45, so the angle measures 55 degrees.
All right, and then it would be the same for the other one, right? Because they're the same measure.
Good question. Yeah, if you check it, if you put 9 into the other one, you get 7 times 9, which is 63. 63 minus 8 is 55 degrees. It's a great way to check that you've done it correctly.
Okay.
Okay, we're up to 18. If I can find it, there's 18. This one, it does matter which angle you find, and I'll explain why when we get to that step. But you have to decide, like the first part of this question is decide, okay, are these equal? These angles that I'm looking at, are they equal or do they add up to 180?
They add up.
They add up to 180, excellent. So x plus 106 plus x plus 90 adds up to 180. So we don't need the parentheses. So it's 2x plus 196 equals 180. We're going to subtract 196 from both sides. So that's 2x equals negative 16. Divide by 2, so x equals negative 8. It's not asking for x, though. It says find the measure of the angle indicated in bold. The bold one, oops, sorry, I went way by it. This looks like the bolded one here.
Yeah, the top one.
Yeah, so we're going to put negative 8 in for x. So it's negative 8 plus 106 is the bold one. So that gives you 98 degrees. All right, I think that's all of them. No, is there 19 here?
Yeah, I think
There's
it's
a
at
19.
19 and 20.
Yep. I don't see 20.
Okay.
I
think I can do 20 on my own, but I know how to do
Okay,
it.
you're welcome to send a picture if you can, but some of them didn't have the problem number identifier with it. But I'll snip in 19, and we'll go through that, of course. Okay, so it's I'm repeating myself. It's the same question every time. Are these equal or do they add up to something? And that's what you're trying to decide here. These are on alternating sides of the transversal that cuts between the two parallel lines.
They're equal, right?
They are equal. These are alternate interior angles, and they are always equal. So 13x plus 8 equals 17 plus 12x. All right. So we're going to solve this. I'm going to subtract 12x from both sides. That gives you just x plus 8 on the left equals 17. Subtract 8, so x equals 9. But again, that's not what they're looking for. They want the bolded angle. The bolded angle is, I guess, this one. So we're going to bring that down here. We want 17 plus 12 times 9. So 17 plus 108, so that's 135 degrees. So again, the main takeaway from everything we've done so far is they're either equal or they add up to 180. If you find x, make sure that it actually wants x. Sometimes you have to put x back into one of the expressions or the other. If you've got 20 on your screen, is it the x plus 147, 57 plus x?
Yeah.
Okay, let me snip that one in. I actually had grabbed that one earlier. I was like, hey, which one is this? And now we know it's 20. All right. Okay, we're missing the top half of this, but just there's a line here. These are on the same side of the transversal, same side. They're consecutive. That means they're right next to each other, one and then the other. Do these add up to something or are they equal?
They add up.
They add up. In fact, they add up to 180. Okay, so we got 2x and then 57 plus 147. 7 plus 147 is 154. Add another 50 to it, that's 204. So we're going to subtract 204 from both sides. That's negative 24. And we're going to divide by 2. So x equals negative 12. Is that what it wants, though? Is that the answer?
No.
No. You have to go back, say, okay, it's really x plus 147. So negative 12 plus 147 is 135 degrees again. All right, so whenever you get a chance here, send over that problem of the week or question of the week, whatever it is. If you could send it directly to learning@mathbymatthew.com, that would be preferred. But I'll get it regardless. It just goes to different places.
All right. All right. It's in like a black font. I don't know why, but it's still readable.
Okay, looks like I've got this got this problem here. So it's something about three friends. I'll copy that in. Yeah, black text is always weird. Okay. Three friends after seeing the movie Hunger Games. Okay, not important, not important. After dinner, they paid their bill and noticed a bowl of mints at the front counter. Okay, Xander took 1/3 of the mints, but returned 4 because he felt a momentary pang of guilt. Zandon. Nick took 1/4 of what was left, but returned 3 for the same reason. Chad took half the remainder, but threw 2 that looked slobbered on back in the bowl. The bowl only had 17 mints after the raid was over. So this question is it's a standard question that gets asked. Most math problems are solved going forwards. This one is solved by going backwards. If you tried to solve it forwards, you would make a table. You would say like, okay, um, let's just make a guess. So I'll give you one example of that. Um, let's say there was 300 to start. So Zandon, he took 1/3 of the mints. So how many did he take?
100.
100. So that means there's now 200 in the bowl, but then he returned 4. So there's really 204. Is that okay?
Yeah.
Nick took 1/4 of what was left. So that's where it gets a little harder. What's 1/4 of that? Well, 1/4 of 200 is 50. 1/4 of 4 is 1. So he took 51. So that means we're down to, so maybe I'll start, this is 1/3. This is +4. So then there's now 153. But then he returned 3. So that means there's now 156. So this is kind of that, and that's kind of a 4th. Okay, and then Chad took half the remainder, so half of that is, what's half of 156? 78, right? And then he put 2 back, and he had so +2, so there was 80. Is that 17?
No.
No. So you could do this sort of, you're like, well, he must have had less than 300 to start. Would you agree with that?
Yeah.
Right. So you might, like what's a number you might guess after this?
Like 250.
Go down smaller. So let's try 150. Okay. So there's sort of, there's either approaches, you either like cut it in half or by 10. That's kind of like a common way that if you're trying to guess something, you either really change it a lot by dividing it by 2 or by 10. Okay, so the first guy takes 1/3 of the mints. That's 50. So there's 100 left over. Then what? It says he adds 4, so you're back to 104. 1/4 of them are taken. So that's 26 this time. All right, so that means there's 78. Is that right? 1/4 of that's 26. Yeah, 78. And then add 3. So that's 81. See, I can't take a half of that. So that number's not right. Okay. So you can see how this is like a problem. Do you agree with that?
Yeah.
Okay. So the way to do this backwards, I'm gonna repaste the problem in because none of this was helpful, but oh, come on. Sorry. This Control Z, Control A. Come on, get all that. Make it so that everyone can see. Yay. Okay. The way you work backwards is you start with this answer right here, 17. So when a person puts two back. Where does he say that? He threw two back. That means, like, here it's adding, but you actually subtract it. It's because you're undoing the operation. So that means that there was 15. That when Chad took half the bowl, but then threw two back. Sorry, I'm getting caught up here. Let me back up here. So let me back up here. Let me give you the answer. So there was 38. There was 38, but when Chad started, so Chad started and there was 38 in the bowl. He took half. Okay, half is 19, but then he threw two back, so that got it to 17.
All right. Okay.
Okay, do you follow that?
Yeah.
Okay, so we know how many were in the bowl when Chad started. The Chad started, there's 38. Because he took half out, 19 up. Let me put two back. That's not right. Sorry, I'm getting. This is not. Let me restart here. Chad took half the remainder, but threw two that looked slobbered on back in the bowl. I'm sorry. When Chad started, there was actually. Let me start this again. Okay, sorry, I really apologize because I'm not making this clear. So the bowl had 15 in there, okay, but then Chad added two to it because it said he threw two that looked slobbered on back in the bowl. But originally, so there's kind of like the start here is that there was took half, and we'll say of 30 here. So half of 30 is 15. So Chad got 15, and the bowl had 15 in it. Do you agree with that?
Yeah.
Now Chad took two from his portion and put them back in the bowl to get 17. You follow how we did that? Is that okay?
Yeah.
So Chad took half of 30. There's 30 in the bowl. And then 15 went to him, 15 were left in the bowl. Then he took two from himself and put it back in the bowl. Okay. Nick, now we're going to start right here with Nick. So when Nick is done, there's 30 in the bowl. So he returned 3 for the same reason. Okay. So Nick, we don't know how many Nick had, but we know that he takes 3 from his pile and he puts them back in the bowl, and the bowl had 30. So it had 27, but his 3 made this go up to 30. Do you follow that?
But where did the 27 come from?
Because we don't know how many. We know that he put 3 back to get to 30. So the only way you can get to 30 is if there were 27 in the bowl.
Okay. Yeah.
Okay. So Nick, but at some point, so Nick took a quarter of what was left, but there was 27 in the bowl at this point. So I'm losing track here. Okay, so let me give you the answer here. Nick took 9. Okay, and I know that because there was 36, and a quarter of 36 is 9. And then 36 minus 9 gets you to the 27. So Nick took a quarter of 36. A quarter of 36 is 9. That left 27 in the bowl. Then Nick took 3 from his pile. So now he's down to 6. His 3 went into the bowl for 30. If that's not clear, we can run through it again, but we'll also get to run through it again when we start from the beginning. Okay. So Zandon, now we're up to Zandon. Okay. So Zandon, here's what happened with Zandon. He took a third, but he returned 4. So when Zandon's all done, there's 36 in the bowl. Well, the bowl had 32, but somehow he returned 4. 4 were added to get to 36. Okay, so there's some number here that 4 were taken that went into the bowl. And it said a third of the mince. Okay, so if we started with 48, a third of the mince that went to Zandon, that's 16. Do you agree with that?
Yeah.
48 minus 16 is 32. That's how we got there. Okay. He took 4 of his, put them in there to get to 36. Okay. I don't think that was super clear, but here's what we're going to do. We're going to paste this problem one more time, and we're going to go through it from the beginning, knowing the correct answer. This is just the way the instructor does it. So, okay, they started. So we know that there were 48 in the bowl to start. Okay. All right. So Zandon took a third of the mince. How many did Zandon take?
16.
16. Okay. How many are left in the bowl? 48 minus 16, right?
Yeah.
What is that?
32.
32. He returned 4 mince. How many does the bowl have now?
36.
36. Okay. So now we're up to Nick. Nick's over here. He took a quarter of 36. What's 1/4 of 36?
9.
9. So how many are in the bowl? 36 minus the 9 is?
27.
27. Okay. But then what did Nick do? So I feel bad. I don't need 9. He takes 3 and adds it over here. So there's 30 in the bowl. Okay, now we're up to Chad. Chad took half of the remainder. So how many did Chad get?
15.
15. How many were left in the bowl?
15.
15. Okay. But then Chad said, oh no, I feel bad. I'm going to put 2 back. So he went down by 2, so that went up by 2 to get 17 back in the bowl. Now, as a reminder, I'm going to send this to you as a PDF when we're all done, so you'll have the solution to this. But notice, I'll just point this out here. Notice if we had just tried to keep guessing and checking. Let me slide this back over. We went down to 150. Our final answer was 48. So we would have had to go down again, like to 75 or to 15 and then go up to 30. Like it would have taken us 3 or 4 iterations to get there. So the guess and check method isn't really the best one, but it could be done.
All right.
Okay, what else would you like to look at today?
I don't know if there's anything else. Let me check.
Yeah, please check, and I'll stand by here.
Oh yeah, there's something.
All right, I'll wait for you to send it over.
It's gonna take a while. There's a lot. I know there's a lot.
Did you say you sent it?
I'm sending it.
Okay. All right. I'm checking my.
All right, it's uploaded.
All right. Checking.
Oh, they haven't sent yet.
Okay.
All right, I think I sent it.
Checking. Come on. I noticed your email has a baseball reference in it. Are you following the playoffs?
Not as much, but yeah, a little bit.
Okay. All right. I see you get sent some new problems here. I'm going to snip in number 1 and we'll see how we can do. Okay. Whoa. All right. Okay. Name the shortest segment from the point to the line. Okay. So I think it wants X. It's asking for this.
Name the shortest segment from the point to the. I don't even.
It's segment PR. I think we would need to know this value to calculate X. So I think unless there's more to it here, I'll look ahead to the next question. It's just PR. Does it look like there's a way to do that? Right, an inequality for X. Oh, that's way down the road. Okay, so there's 7, 8, 2. We're up to 2. Write an inequality for X. Okay. Is there anything else provided besides this, like the length of QR or?
No, this is all it says.
Okay. Well, I don't think I can answer this for you. I can just sort of talk around it because I don't know. Let me call this A, or maybe Y is better. Y is better here. What we do know is that X squared plus Y squared equals 3.5 squared. That's the Pythagorean theorem. I call it PAG for short. We also know that the hypotenuse is the longest side. So we know that like X has to be less than 3.5. I think that's all it wants, but I'm not sure. It also is the case that X has to be greater than 0 because it's got to be positive. So it might be that you combine these and say that X must be between 0 and 3.5. I'm not sure though, so I hope you get some clarity on what they actually want.
Wait, let me put my notes in the class because I know we're doing something similar to this in class. Oh, no, never mind. Yeah, I don't know.
That's okay. We'll keep going through a few of these. 3 and 4 are similar. There's nothing wrong here. It's just this is the way that this book or online website chooses to refer to stuff. Name the shortest segment from the point. See, it should say like point J.
Yeah, because you don't know where to
You don't know
start.
which one it is. I'm assuming it is, but name the shortest segment from the point to the line. So I think it wants JH again. And it tells you that JH is 11. Okay. Because the next problem, it says to write an inequality, like it refers to the same picture. Let's grab that and let's snip it in. So in the next picture here, it wants an inequality for X. Well, X is part of the hypotenuse, okay? And the hypotenuse is the longest of the three sides of the triangle. So X plus 4 is the biggest side. So it has to be bigger than the other side. So this is like saying the hypotenuse has to be bigger than another side. So if you solve this inequality, subtract 4, you get X must be greater than 7. Five and 6 look very similar. I don't know if you have a if you've got this up on your side, but it's very similar. Let me paste this one in. So I think again it's saying name the shortest segment from the point to the line. I mean, I got to be thinking it's A. Point A. So what is that segment? AB, right?
AB, yeah.
But why do they give you all this other stuff? I don't know. Now they want you to write an inequality for X in part 6. So this AC is what is X minus 3, and it has to be the biggest side because it's the hypotenuse. So X minus 3 must be greater than the other side. Well, the other side is 6. We assume it's I guess. I mean, we assume that. So we add 3 to both sides and get X must be greater than 9. So odd. Okay. 7. Okay, this is maybe a better picture of this. Just as sort of an aside, I mean, this is not very interesting. Like I'm not even excited about this, so I don't expect you to be either. It's kind of a dull topic. Because I mean, if you need to know the length of something, you just go out and measure it. Name the shortest segment from the point to the line. So I think it's asking about point U, okay? And you have a choice here. It's either UT or it's UW. And it might visually look like UT, but you can't use that as a justification. So the way you figure this out is, okay, well, like this is X plus 4 and this is X. So pick a number. Like let's say X is 3. Well, UT is now 3 and UW is 3 plus 4. Is that okay?
So it doesn't even matter, it just has to be less than 21.
Well, we're going to get to that, but do you agree that UT has to be smaller than UW because whatever UT is, you're adding 4 to it to get UW?
Yeah.
So that's how you know that it must be UT. Like it's like, oh, well, whatever it is, I'm adding 4 to it. Question 8 wants you to figure out, okay, well, 21 has to be bigger than X plus 4 because it's 21 is the hypotenuse. The hypotenuse has to be the biggest side. So if you subtract 4, you get x has to be less than 17. This thing has to point at x. It still points at x. So x must be less than 17. So whatever it is, let's just say it's 15. Well, 15 plus 4 is 19. So that's why UT is always the shortest. The longest would be UW. All right, this is a great place for us to stop. We got through quite a bit today, so I'm very pleased with that. I appreciate you scheduling, and I'm going to send this out to you as a PDF shortly, and the video will be soon to follow.
Okay.
Thanks so much, Maddox. Have a good night.
All right. Bye.
Bye.